Okay, this video is going to be on the quadratic formula. So, quadratic formula. All right, so first of all, when are we going to use the quadratic formula? Well, we've been solving quadratics using factoring, using the square root method, complete the square, all these methods. But they all had pretty answers. So the quadratic formula is going to give us an answer to any quadratic, whether the answer is pretty or whether it's imaginary or whether it is just a decimal, ugly. So let's look at what the quadratic formula is. First of all, your quadratic has to be in the form, I'm going to show you this through the book. Okay, so your quadratic has to be in the form ax squared plus bx plus c equals 0, where a can't be 0. Basically, you have to have an x squared, a number in front of x squared. It can't just be x and a number, or it's not a quadratic, that's linear. So here is where you get your numbers from. You're going to use the number in front of x squared, the number in front of x, and the number by itself, and you're going to put them into the formula here. All right, and that's going to give you your solutions. And that's it. A lot of people make this a lot harder than it is. This is just going to be your solutions. One other thing I want to make sure I point out, I'm not going to go over a lot of examples of this, but this is the discriminant. Okay, so the discriminant is just under the radical. So notice it's got the b squared minus 4ac. On our formula, that's what's under the radical. If what was under the radical was greater than 0, right, then we have two solutions. If it's equal to 0, you have one solution because the square root of 0 is 0. You don't have the two different solutions. If it's less than 0, you don't have any real solutions. They're going to be negative. They're negative under the radical, but they're going to be imaginary. So when we're looking at this formula, and we figure out what's under the radical, if we get a negative there, we know that there is no real solutions. It never really crossed the x-axis. The little parabola is up too high or down, upside down, down too low. If this is a 0, then you only have one solution because the square root of 0 is 0. You don't get the two solutions. Like you do in the other ones. So just pointing out the discriminant is really still the formula. It's just under the radical part and deciding whether or not your formula has real answers or your problem has real answers. And I would really use the discriminant in real life all the time and not necessarily do the whole quadratic formula. I would use a discriminant when I just want to know if this is going to work. This is a business and this is an equation for a business problem, and you have a negative under the radical. Well, you know you're going to have imaginary, and it's probably not going to work. Okay, so let's look at a couple examples. Let me look at, I think I'll only do one, maybe two, but what if I have x squared plus 10x plus 2 equals 0? So it's set up perfect the way I want it. And do notice that I could use complete the square on this. I cannot use just a square root idea because I have an x term, but I could use complete the square. But the formula is better. So let's look at what we do. We find a, b, and c. A is just the number in front of x squared, which we assume is a 1. B is the number 10, and the number by itself is 2. If this would have been like minus 2, you would have had a negative with the 2. These ones were all positive. Okay, then from here, my formula says negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And most people mess up right here, b squared. Okay, when they have a negative b, they somehow get a negative in here because they used their calculator and messed it up. Anything squared is positive. That better be a positive number right there where the b squared is. And that's probably where you're making mistakes. So let's put our numbers in. 10 is positive, so when I say negative b, it just says change the sign of b, so it's going to become negative 10. B squared, again, it's 10 squared, or 10 times 10, which is 100, minus 4 times a was 1, times c, which was 2, all over 2 times a, or 1. Then all we do is simplify under the radical first. You have to do times first. I like this method. Okay, here's my calculator. Oh, maybe it's kind of like I don't know, shining weird on it. There we go. I was like, I don't, it's my light right above me that's like glaring. Okay, so like, let's do 100 minus 4 times 1 times 2, just like that. And I could have done this in the order in which we saw it, which we could have gone negative and leave the negative. 4 times 1 is 4, 4 times 2 is 8, and minus 8. But a lot of people make mistakes. Look, you can just put it in there and get the 92. Or you can times out these ones here, get your 8, and then 100 minus 8. The problem is if this would have been a negative 2, you have a double negative that becomes a plus, and I don't know, just an area where for some reason people just mess up on their simple math and their simplification. So then we're going to have 100 minus our 8 over 2, which is going to reduce to our square root of 92 over 2. Now you're almost done. We have to look from the section before, can we simplify this anymore? Well, the square root of 92, does anything divide into 92 that we can take the square root of? Well, I think of the numbers I can take the square root of. That's going to be 4, 16, 25. Goodness gracious, I'm running out of ideas here. Anyway, so 4 goes in there. You know, 36, 49, those are all our perfect squares. So those ones all go in. You have to check it, which one goes into 92. For this one, 4 does. So it's 4 times 23 is 92. So I'm going to break that up in the square root to 4 times 23. And I'm going to take the square root of 4 out and write it in front. So the square root of 4 is a 2. So I can take it out having 2 square root 23 over 2. Okay, almost done. The last thing you have to check, does this number here divide into both these spots? Both. This is a plus and minus. It's not a time, so it has to go into both spots. Then you can simplify one more time. It does. So 2 goes into negative 5 or 10 negative 5 times, plus or minus 1, which you can leave off. And that is your final answer. We can't simplify 23. If we wanted a decimal, we could. We could say, okay, say we wanted the decimal answers. We could say, sorry, I'm trying to get it to where, like, there we go. So you could say negative 5 plus, and then of course it's under me, right? What did I have? The square root of 23. So my square root's there, 23, and that would give us a decimal here if you wanted the decimal answer. So maybe it's a word problem or something and you don't want decimal, or you want the decimal. So minus, you could also do the minus square root 23. And it's negative 9.7. So there's your two decimal answers. So you can still get a decimal answer, or you can leave it in radical form. Okay, so let's do one more example. What if I have imaginary? So what if I have some eyes in there? Because that one's a little hard for a lot of people too. So let's see. What if I have 2x squared minus x plus 2 equals 0? So it's already in the set equal to 0 form. Remember, the 0 is where y is, so sometimes you might be given it as y equals or f of x function notation equals, and you're asked with where the zeros, or you might be asked with where the x-intercepts are, or you might be asked for the solution. So it's like a lot of things asking the same thing. So you put the 0 where the y is and then you solve. So let's see what our A, B, C are. A is 2, C is B is negative 1, and C is 2. So let's put that in. So negative B would make a double negative, so you get positive 1 plus or minus the square root. So obviously it just changes the sign of B, the negative B. Here, b squared, here's where I'm saying you don't want a negative 1. If you put negative 1 squared into your calculator wrong, you're going to get negative 1. We know negative 1 times negative 1 is positive 1. Minus 4 times A times C, all over 2 times A. Okay, and A was 2 here. Okay, so we have to do this part first. 4 times 2 is 8. 8 times 2 is 16. 1 minus 16 is going to give us negative 15 under that radical. So I have 1 plus or minus the square root of negative 15 over 4. And again, this is why we had to look at imaginary numbers. Well, we're pretty much done, or very, very close, but we have to take this negative out and know that it represents I, an imaginary number. So we would take that out. So we have 1 plus or minus this kind of cursive I, square root 15 over 4. They do not like you blending your real answer part and your imaginary. So they want you to split this up. So what you do is, 4 divides into everything. So you can think of it as 4 dividing into each piece, each term before the plus and minus. So this can become 1/4 plus or minus I square root 15 over 4. And that's it. Like, that's our final answer. Now, this is 2 answers, so don't think of it. I love doing it with the plus and minus, so you don't have to write everything twice. But we have 2 answers, plus I square root 15 over 4, or 1/4 minus I square root 15 over 4. These are your 2 answers. So in some instances, you might be asked, what specifically are your 2 answers? And you have to be able to know that. And so we have putting them together, taking them apart. There's an example with a big I in it. And I think you'll be okay with the rest of them. So let me show a couple things in the textbook that I have. This isn't necessarily the same textbook you have, but it works because it has it in there. So when you're given them in the function notation and you're being asked what are the zeros of the function, that is like short term for put a 0 where the g of x or f of x or whatever function notation you have. Put in a 0 here and solve. Okay? And you'll see the answers over here on my side that are like all, include I's, not I's. So you have all sorts of different kind of answers. All right. Now, can you use this quadratic formula for any quadratic? Yeah, you don't like complete the square? Great, you have to know it for the test and for vertex form, but otherwise, you can use this formula for everything. Are you not good at factoring? Fine, then use the formula. So this is one way to always be able to solve a quadratic. All right, that's the end of my little short video for today.